Okay, I want to build up to these hardest ones, but I'm going to start at the top, okay, and build towards those and trying to solve exponential equations. So let's go to the top. We first said, and this is a review, that if we're looking at the bases are the same, then the powers must be the same, right? Because the only difference is that this is an x and this is a 6, otherwise it looks the same. So we said if 2 to the x equals 2 to the 6, we must have that x equals 6, right? Bases, same, powers, same. That's the only way they're going to work. Okay, so in the same one here, if the bases are the same, then the powers have to be the same. So we have x plus 2 must equal 4, because that's the only difference. It's 5 to the something. This must be the same as that. And then we have to solve it. And we said, okay, I talked about what's on the letters on the left and numbers on the right. We said, okay, what's going on with this 2? I want to do the opposite, right? So I said x plus 2, and then I need to take away 2 from that side, but then I have to be fair, so I'm going to change my color back, is equal to 4, but to be fair I have to take away 2 from that side as well. Alright, it keeps the balances, keeps it all balanced, the equation balanced, because I do the same thing to both sides, and now I've got x, 2 minus 2 is 0, I can put plus 0 if you want to, equals 4 minus 2 is 2, but most people aren't going to write plus 0, they're just going to say x equals 2. Okay, so we've solved it. How do you verify it? How do you know that the answer is right? Well, visually looking at it, you can stick the 2 back into here. So if I said left side, and this is the fancy way, I'd said 5 to the x plus 2 is the same thing as 5 to the, well, we said if x is equal to 2, we know that 5 to the 2 plus 2, or 5 to the 4. We know the right side is 5 to the 4. We can say, therefore, the left side equals the right side. And then if you want to get really fancy, you say QED, which is Latin for quid est demonstratum, just a fancy way of doing a proof. Okay, let's try the little harder ones here. 11 to the 2x equals 11 to the 8, so we know that 2x must equal 8. And we want the letters on the left, numbers on the right, one equal sign per line, and be fair. So we say, what's by the x there's a 2, what's it doing? It's multiplying, so I have to do the opposite to both sides. The opposite of multiplying is divide, and I have to do it to both sides to be fair. 2 divided by 2 is 1, so I'm left with x, or 1x equals 8 divided by 2 is 4. How about this one? X plus 1 equals negative 5. Alright, so I want to get rid of that 1. That's the one by the x. What's it doing? It's adding, so I'm going to minus 1 from both sides. Let me write the original one in here as well. X plus 1 minus 1 equals negative 5 minus 1. 1 minus 1 is gone, or 0. X equals negative 5 minus 1 is negative 6. And if you put a box around it, you know you're done. Okay, last one, 2x equals 7. Same idea again. What's by the x? There's a 2. What's it doing? It's multiplying to the opposite to both sides. Divide both sides by 2. And we're left with x equals, you can leave it as 7 over 2, or you can leave it as, what's that, 3.5, whatever you want. Okay? Alright, so let's get down to the harder ones then. So 2x equals 8. Now the bases aren't the same, so I can't do the same trick. But I need to make the bases the same. So if I said 2 to the x equals 8, what if I said 2 to the x is equal to 2 to the something? Well, 2 to the what makes 8? 2 times 2 times 2 is 8, so then it gets a little trickier. Now we can go ahead and say, okay, now the bases are the same. And so we can say that x must equal 3. Alright, so it gets a little bit trickier. Same thing on this one. If 5 to the 2x equals 25, I need the bases to be the same to get this trick to work. So I got 5 to the 2x equals 5 to the something. So now I can say, okay, well, 5 what is 25? 5 squared is 25. Now I can say 2x is equal to 2. I want x on its own, so I say what's by the x? There's a 2. What's it doing? Is multiplying, so I do the opposite of both sides. I divide both sides by 2, and I get back to 2 divided by 2 is 1. I'm left with x equals 2 divided by 2 is 1. Okay? The next one's even harder. 3 to the x equals 1 over 9. I want to say 3 to the x equals 3 to the something. Oh, that gets a little tricky. So let me take a break here. I'm going to say 1 over 9 is the same thing as 1 over 3 squared. Are we okay with that? Alright, so if that's the same thing as 1 over 3 squared, I can say that's the same thing as 1 squared over 3 squared, because 1's a special number, or 1 over 3 big bracket squared, or 3 over 1 to the negative 2. That got a little tricky, right? So now I could say, okay, 3 to the x, so that's my little aside, is the same thing as, instead of 1 over 9, I'm going to say it's 3 to the negative 2. Okay, so I kind of wanted to force it into 3 to the something, but I couldn't figure out what that something was, so I had to get it around until I got a 3 on the top. So now I know that x equals negative 2. Okay, last one. I give another example here. 2 to the x equals 1 over 16. 2 to the x equals 1 over 16. I want to say 2 to the x equals 2 to the something, so how are we going to work that out? Let's do it over here. 1 over 16 is the same thing as 1 over 2 to the 3. 2 times 2 is 4, times 2 is 8, times 2 is 16, 4. 2 times 2 times 2 times 2, okay? Or I could say that's the same thing as 1 to the 4th over 2 to the 4th, or 1 over 2 all to the 4th, or 2 over 1 to the negative 4, or just 2 to the negative 4 if you want to. Okay? So then I know that this must have been negative 4. And then I'm left with, okay, now the bases are the same, so I can say x is equal to negative 4. Not easy, but you got to take your time. If the bases are the same, the exponents must be the same. So in this last set, I had to force the bases to be the same.